Hello everyone. My name is Dr. Raj Dandekar. I graduated with a PhD in machine learning from MIT in 2022, and now my vision is to make AI accessible to all, and I've discovered my passion for teaching and for learning machine learning and AI. I would first of all like to thank Ashutosh for inviting me to his channel for making this video, and today I'm very excited to make this video in which I'll be talking about how I transitioned from being a mechanical engineer to a machine learning engineer, that too within a matter of 3 years. So, not many people might be knowing about this, but when I graduated from IIT Madras in 2017, I was a mechanical engineer and I had graduated with a BTech in mechanical engineering from IIT Madras. And at that time, I had not heard about too many details of machine learning. I did not know too much about machine learning at all. And I had joined MIT for a PhD in mechanical engineering. At that time, my goal and my vision was to become professor in mechanical engineering. What happened was when I was doing my PhD, after 2 years, I went to a career job fair and I saw that the number of jobs for mechanical engineering were really decreasing. Almost all the companies and all the startups which I saw needed someone with a machine learning expertise and machine learning skill. That was a really big wake up call for me because I suddenly realized that I need to have these skills if I want to have a competitive chance in the job market. So I started losing interest in my main field of mechanical engineering. Another big problem for me was that I was scared to make this transition to ML because I had this belief that I was not a computer science or a CS student and only CS students can transition to ML. But many things happened in the next 3 years, and I not only switched to machine learning, I found a new research group. And when I graduated from MIT, I got a PhD in machine learning. Today, my papers have 400 plus citations, and I also got multiple job offers. This video is an attempt to explain how I was able to make this transition in spite of the fears which I was having, in spite of the thoughts and the initial belief that I don't know anything about machine learning and I'm a mechanical engineer. How can I make this transition? If anyone watching has such self doubt right now, I hope this video will serve as an inspiration for you. Okay, so towards the end of my PhD, here are some of the papers which I published in machine learning. Most of my work was in applying machine learning to COVID 19. So we collaborated with a number of governmental agencies in the US, Europe, etc. And these were some of the articles which were published. Not just that, as I mentioned, I also got job offers from companies such as Julia Computing, Amazon, and I received interview offers, etc. This was without me trying to sell my profile aggressively. Recruiters were reaching out to me through LinkedIn to interview for the machine learning position. So, let me start talking a bit about how I made this transition to machine learning. So at that moment, when I was in the middle of the transition, it was difficult to know how things are proceeding. But when I came back to India after finishing my PhD, I gave it a lot of thought as to how I could transition to ML within a matter of 3 years so that everyone else could do it too. I realized that there are three main reasons which actually helped me a lot to transition to machine learning. The first reason is that the way traditional machine learning is taught is not meant for engineers. I was lucky enough to stumble upon and discover a new field which is called as scientific machine learning. I'll also talk about this field in today's video. Second, when I was thinking that I cannot transition to ML and it's only meant for CS students, I met a senior who told me that you can transition to ML. It's completely possible for you to do that. That gave me the belief and self confidence to work hard towards this transition. I think this video will serve as that inspiration to many of you students. Third thing, which is extremely important, is that I could have just done some quick projects in machine learning and added it to my resume, as many students are doing these days. But I did not do that. Instead, I focused on research. I focused on getting my projects to a publication level so that that could carry a lot of impact on my resume. So now let me go through each of these realizations sequentially. The first realization, as I mentioned, is that the way traditional ML is taught is not correct for engineers. Let me explain to you how and why. So let us do a live demonstration of this. Let's actually see the course contents of MIT 6.86 course, which is the free machine learning course offered by MIT. If you look at the syllabus of this course, you will see that they first teach linear classifiers, then they teach non-linear classifiers, regression, neural networks, then unsupervised learning and reinforcement learning. This is typically the common syllabus which is taught in many of the free machine learning courses which a beginner takes. I want you to now look at the projects which are done in these courses. So here is a project called Automatic Review Analyzer. Here is a project called Digit Recognition. Here's another project called Collaborative Filtering for Movie Recommendation, etc. I have made a list of all of such projects over here. Many commonly taught beginner projects are Automatic Review Analyzer, Digit Recognition, Collaborative Filtering for Movie Recommendations. Then there is a text based game or Sentiment Recognition. Do you see the problem with these projects? The main problem with these projects are not meant for engineers at all. How is uh, digit recognition or automatic review analyzer related to mechanical engineering or biological engineering, or how does it appeal to a physicist? If you are a nuclear engineer or if you are an economist, how are these projects even relevant to you in the first place? So there are many problems with these projects which are usually taught for beginners. First, these projects don't really show you how to combine machine learning with your domain specific knowledge. Many students belong to domains such as mechanical, electrical, chemical, civil, biology, physics, etc. These projects don't show you how to combine machine learning with that domain. Second, these projects are toy projects. Almost everyone does these projects and almost everyone has them on their resume. So it's very difficult to publish research papers using these toy projects. These are not very serious projects. They are a great place to start, but don't add these projects on your resume. Of course, you can get started with these, but don't think you are a machine learning engineer because you have done these toy projects. And third, and the most important thing is that without leaving your main field, if it's mechanical, electrical, chemical, bio, you should be taught how to integrate machine learning with your main field. This is where actually scientific machine learning comes into the picture. Let us look at these following projects on the other hand. Imagine you do a project like how to use machine learning to model COVID 19 infections in all the regions of the world. Or you do a project which recovers the chemical reaction equation just looking at the data. As a chemical engineer, wouldn't this be an awesome project which teaches you to mix your core knowledge with machine learning? As a physicist, if you are taught to do a project using machine learning to predict black hole dynamics, or as an economist, if you learn how to use machine learning to predict economic market forces like supply and demand, or if you use machine learning for biochemistry, machine learning to analyze fluid mechanics or climate problems. Do you see these projects are meant for engineers, scientists, and data analysts? This is the advantage of the field of scientific machine learning. All these projects come under the field of scientific machine learning, where you mix your main domain with machine learning. If you have these projects, you can do independent research in your field and even publish papers. These are new projects which show how machine learning can be integrated with your original field. You can even include all these projects on your resume. They'll be unique projects because not many other people will have it. Okay, so when I talk about the field of scientific machine learning, I was lucky enough to find a research group which does research in this field. So let me show you that group. The group which I found out was called as the Julia Lab at MIT. This was the new group I transitioned to, and this is one of the leading groups in scientific machine learning. In fact, I owe my entire PhD and this transition which I made to this group because they introduced me to scientific machine learning. In this video, I am also going to talk a bit about what scientific ML is so that all of you who are watching this can know how to transition to this field. Basically, scientific ML mixes science with machine learning. And when you think of science, you can think of ordinary differential equations or partial differential equations. When you mix ODEs or PDEs with neural networks, that is the field of scientific machine learning. So anything which has an ODE or PDE can be thought of as a scientific machine learning problem. So if you don't know what an ODE is, I'm sure you would have encountered it before. Almost everything which happens around us can be represented through rate of change. Let's say you have invested in a stock, and if you want to find out how the stock price changes with time, that's the rate of change. Even when you write down the Newton's second law of motion, F equal to mass times d square x by dt square. D square x by dt square is the rate of change. These are examples of ordinary differential equations. Whenever there is a rate of change, it's an ODE. When you look at simple harmonic oscillator, d square x by dt square plus omega square x equal to 0, that's an ODE. If you look at the logistic growth equation in biology and ecology, the equation is dp by dt, which is the rate of change of population, is equal to r into p into 1 minus p by k. This is an example of an ODE because it shows how the population grows with time. No matter wherever you go, if you go to the field of epidemiology, there is the SIR ordinary differential equation. Ordinary differential equations lie at the heart of many things which happen around us. If you go one step above ODEs, then there is partial differential equations which have more than one variables. So here, if you see, all these equations have just one variable, right? In this case, it's time. In partial differential equations, there is time as well as there is space. I'm not going to go into that right now because the main purpose is to motivate you in this field so that you can also transition to this field. Now, let us actually take a simple problem, and here I want to show you how you can start thinking about scientific machine learning. This is a practical problem which is called as a predator prey problem. Imagine there is a space, a jungle in which there are wolves and there are rabbits. What will happen if wolves and rabbits come into contact with each other? Initially, you might think that the wolves will just eat the rabbits, but it's not as easy as that because if the wolves eat the rabbits, the wolves have nothing to feed on, so they will also die. This is represented by this video. Okay, so in this video, if you observed, the wolf population and the rabbit population vary cyclically. In fact, it can be represented as in a plot like this. This is how the wolf population and the rabbit population varies. This is also called as the cyclic dance. The reason this dance exists is because if the rabbits decrease, uh, if the rabbits decrease, then the wolves have nothing to eat, so then they also decrease. So it kind of goes on increasing and decreasing together, and that's why it's called as the cyclic dance. This is represented by a set of ordinary differential equations. Here dx by dt is the rate of the predator population, in this case how the wolves change with time, and dy by dt is the rate of change of the prey population or how the rabbit population varies with time. If you solve this ordinary differential equation, you will get a graph like this where you will get the population of the wolf and rabbits with respect to time. Okay, so that's all pretty good. This is how the differential equation looks like. If you see, the rabbit population variation depends on the rabbits, of course, but the interaction between the rabbits and the wolves. Similarly for the wolves. Now, let us do some scientific machine learning magic. Let me introduce the story to you. Imagine you are a wildlife photographer and you have collected data of rabbits and wolves. So, you have seen that the data follows a cyclic pattern like this. You have seen the oscillations in the population of rabbits and wolves, but the catch is that you don't know the underlying equations. You do not fully know these ordinary differential equations. So, more specifically, you don't know the interaction term. So this is the ordinary differential equation, right? Let's say you don't know this fully. Let's say you don't know the interaction term. So you don't know the beta xy and you don't know the delta xy. You are a wildlife photographer who has collected data, and you know that of course the rabbit population depends on the number of rabbits, but I don't know what's this term over here. And of course the wolf population depends on the number of wolves, but I don't know the interaction term. So then your professor tells you that, okay, based on the data and based on the limited knowledge of this differential equation, try to find out what this interaction term will be. And this is where the scientific machine learning problem comes into the picture. You don't know this interaction term. Then what you do is you replace the term with a neural network. And since you have the data, you train the neural network based on the data, and then you recover what the neural network represents. And in fact, it turns out that the optimized neural network exactly recovers this interaction term beta xy and delta xy. You see, this is how we are mixing machine learning with ordinary differential equations, or we are mixing machine learning, the power of machine learning, with the scientific nature of the ODEs. That's why it's called scientific machine learning. This kind of a framework, which I told you, integrating neural networks with ODEs, might seem simple, but it's at the heart of a new field which is just emerging right now. In fact, one of the major reasons I could transition to machine learning is because I learned everything to know about this field. So let me show you the paper which I published at the end of my PhD. This was the paper which I published. And if you look at the paper, I started out with the ODE for modeling the COVID 19 spread, and that's called the susceptible infected recovered SIR model. Then, what I did is I integrated a neural network in this ODE, something like this. And then I made predictions based on this new model. So, the predator prey example which I showed you is very similar to what I actually did in my PhD. If you are a student in biology, physics, chemistry, anywhere, any field, think of ordinary differential equations which show up in your field. That might be a start of a scientific machine learning research project for you. And remember the last thing which I mentioned, I did not stop at a project. I could have just got results and then put it in my resume, but I converted my results into a research paper like this, and that made all the difference. Please keep in mind that projects are useful, but if you have a publication, that is extremely more impactful. This is the real way I transitioned to machine learning. I learned the field of scientific ML. I converted my results into a publication, and that added a lot of value to my profile. I want to show you some research papers, in fact, which have used scientific machine learning. Here is a paper on civil engineering, which has used scientific ML. Here is a paper on battery degradation, which has used scientific ML. Here is a paper on chemical reaction modeling, which has used scientific ML. Uh, so, all there are so many fields actually in which the scientific machine learning can be integrated with. In fact, you can take any domain field: mechanical, electrical, chemical, biology, physics, data analyst, economics. You can think of a scientific machine learning problem. So, this is the way I transition to ML, and I think if you learn scientific ML, you can go that route also. One of the best open source and free ways to learn scientific ML is Julia's scientific ML community, which is sciml.ai. I'll be providing the links to this as well as to all papers. You can just go over here, go to the documentation section, and start with the tutorials, new user tutorials, installing SciML software, etc. You can get started like this. So the best way to learn scientific ML is through the Julia programming language. So if you don't know about the Julia language, try searching about it. It's one of the new and emerging languages, and it's awesome for scientific ML. So this was what I wanted to convey to all of you today. Of course, I'll be sharing the links to all of these papers, so don't worry about it. And I'll also be sharing the link to this Julia Scientific ML uh, online free interface, which I just showed to you. In summary, I want to mention these three realizations which helped me transition to machine learning. from a mechanical engineer. First, I did not go through the traditional ML route. It's good start to do these projects, but I learned a new field of scientific ML. That's number one. Number two is I had the belief that I can make this transition. One of the senior told me that you can do it. Sometimes the belief is all you need to make this transition. So I hope this video serves that as that belief for you. I strongly believe that anyone can transition to ML, no matter which field, no matter at what stage of the career you are in. And the third most important thing is that focus on research. Don't just focus on getting quick projects and add it to your resume. People respect research a lot. So these are my three realizations which helped me transition to machine learning. Thank you so much everyone, and I hope you learned a lot from this video. Again, thanks a lot Ashutosh for inviting me to your channel, and I had a lot of fun while making this video. Thank you.